Good morning. Okay, today is Monday, the 13th of August, 2018. This is the nybbles.io daily programming stream. My name is Jeff. I write code every day. I stream it here on Twitch Monday through Friday. I am working on a project called Basecode, which is a programming language that I'm designing, and specifically I am writing the Bootstrap compiler for that. And that's in C++. Hey, flathead screwdriver. My new schedule, where I'm kind of limited to about between 7 and 7:30 in the morning is my cutoff, is going to be more strict here going forward. So I have about 2.5 hours this morning to get some stuff done. So I thought I would do some smaller items. Refactoring on the programming stuff, or on the program class, I'm gonna have to reserve that for my second thing that I do later today. Hey, Crossbow. Because I think any of the refactorings I start undertaking there are going to probably take too long. So one thing that I had out here was adding a no color option to the command line tool. All right, so I'll do this. So the easiest thing to do here at least for now, so is the C++ version of the compiler ever going to be multi-threaded? And I think the answer to that is no. It could be that when I start rewriting it, I think about threading, but for the C++ version, again, the target audience for the C++ version of this is really me. And the compiler is already, I think, pretty performant. Obviously, I haven't started running a lot of complex stuff through it, but I mean, it takes the C++ compiler and CMake, I don't know, a minute to compile this, and I tolerate that. So I mean, yeah. I think it's fair to say I won't be doing multi-threading here. So if it's not enabled, we're just going to return whatever was given to us. I think that's pretty much it. So what that's going to allow us to do, we can call Colorize. And at the call site, we don't have to worry about whether the colorizer, you know, whether the consumer wants color or not. That's controlled at this level. I'll just leave a note. So without the flag, it gives us color. Let's do this. Okay, then let's do, hey, Lori Master. No color. There you go. Yeah, no color. Oh. Ooh. How the hell did that one end up colored? Okay. Ah. Huh. Oh, I'm doing okay. This is weird. That's bizarre. That worked. Okay, that's interesting. So, I have to read up on that. The lambda, yeah, the closure couldn't see the state change on that static. It's interesting. Yeah, I mean, a global's fine. It works. Whatever. Okay. I guess let me run it without the no color. Make sure I actually get color. Yeah. Yep. Okay. So that was pretty much all that one is going to be. So I added a new command line switch. It's optional, no color. I fixed the help or the usage line for the -G. There's no longer an argument there. Added no color to get opt config for that. And then we handle that case. If it's specified, then we set the enabled flag for that to false. I guess now that that's global, let's rename it so it's a little clearer what it does. Okay, so we have the G color enabled global, which the colorizer functions will use to determine whether or not they should actually format the color. Pretty simple. When I rewrite this in Basecode, I think I have thoughts on how I'm going to handle this in such a way that written in Basecode, it'll be much easier to do this. And make it thread safe and all that good stuff. Yeah. So that was it on that one. So the next is compiler should assert numeric literal within range of explicit type unidentifier. So I'm going to go back to my simple file as the Basecode file we're compiling. I created short because I was trying to debug the floating point stuff, and I've done that. Okay, so in our simple test file, what I'm going for on this one is we know that, so we have a specific type. We have a an explicit type declaration here, not inferred. Because if it's inferred, the compiler is going to do the right thing in the context. So here, if we try to assign 512, that should be an error. Now, right now, I think that's just going to, like, bad things are going to happen. Or it's just going to silently stomp on memory. Yeah, it's just going to do things it shouldn't do. But that should be an error at compile time, because we know what the type of this variable is. That's an error. If it's outside of range, the inference will fail. It won't be able to find a valid type. So we know the type. We know this is a literal value, and we can compare that to what the valid range of that type is. And even if this were a variable, that was a U16 or U32 or U64 or an F32, whatever, some other type, essentially than U8, that's an error. Because we can't fit that. Now, if you cast it, that's different. And that's where we start getting into the compiler perhaps suggesting, okay, hey, that doesn't fit. You could cast it with truncation, whatever. Okay, so let's go to trying to think of where we should put that. Because there's two possible points in time where we could assert that. One is when we're creating the assignment from the AST node. The only problem with doing that test here is we might have deferred type inference going on. So in this case, you know, this is a built-in, we're going to know what it is, but we don't know that. In any given situation, we don't know that the type is necessarily so this could be a user-defined type that yeah. So we really can't do it at that point, not easily. It's not the camera, it's just the way that I'm getting the image. It's temporary. I have a cable on order. So the other place we could do this, which would be at this point, we're kind of guaranteed. We have everything, or we should. Because this compiler doesn't have forward declaration requirements. Order is not important. So the very last file that gets imported may be the file that defines half the types for the program. So in the process where we're translating the AST into the model, there's every likelihood that there will be lots of deferred lookups, right? Because we're not forcing people to, it doesn't matter what order you do things in, right? I could use a type here and I could define it down here and that works fine. But the trade-off for that is that, you know, you can have a model that's translated from an AST, and then before we can actually do anything with it, we actually have to go resolve those. Hey, Metal Snake, Cubisus. Yeah, this is a DSLR. Although, speaking of white balancing, and good morning. I'm gonna pick a better, it's a little, yeah, right about there. Or do I do it here? Okay, so let's walk through it. There are phases to the compiler. Phase one is we're taking the source file and turning it into the AST, okay? The AST is there's some validation that's happening there, but that's largely just parsing and grammar. We're not doing any type validation, we're not doing anything complex at the AST phase. The AST is then fed into the compiler infrastructure, and the compiler translates the AST into a more concrete, what I'm calling a code DOM, okay? That DOM, like I say, is much more concrete than the AST. So we start nailing things down. The code DOM has types eventually. It has relationships to other things. All these things get worked out, right? Symbols get looked up. We assert that things exist where we think they exist. But, so let's say that I have a user-defined type up here, or I have a variable, okay, that is going to be a user-defined type. So foo is a box, okay? So box doesn't exist at all. This is going to be an error. Or it should be. So I guess we're going to test that. Okay, right. Doesn't know what box is. We can't find it, right? So now there's I could define box up here. So I could say box is a struct that has a number in it that's 32 bits, okay? So now it should find box because box is defined. So what's going to happen here is box will actually be resolved at the point that foo is declared. But I can also move box down here. Now what'll happen is the translator will take the AST, it will make the model to the best of its ability, but this will, for the duration of compilation from here until this is defined, and actually technically after it's defined, this will be a placeholder called unknown type, and it'll have information about what was requested. So then once all the model is translated, then we go back and we say, okay, here are all these types that were, these identifiers that had types were unresolved. Can we find those types now? So at the point in time where the variable declaration takes place, I don't know. Well, I do, but even if I know it's not unresolved, I mean, if it's resolved, okay, I could have a case where I check it right then, but if it's unresolved, I'm gonna have to defer it anyway. So that's what I'm talking about when I say that things may not be, I have to wait until the model has been resolved fully to be able to go through and do all this type checking. See, if I take that out, it still can't resolve that, right? So even though that this happens later in the file, the way that the resolution works, those things get tidied up after the fact. Now I could do it, you know, and that's kind of what I was starting to think about, was when we actually tell the program, which is the parent node of the entire DOM, to start generating code, at this point everything's been resolved. All unresolved identifiers have been located, all unresolved types have been, you know, found and corrected. So we have everything we need here. So I'm thinking this would be a logical place to do it. I mean, technically, I could I'm not sure where what your doubts are. Well, it's not literal range checking per se. I'm using that as my, okay, so to clarify, I'm using the literal scenario because it's easy to start with that, but that's not really what the implementation is going, it's not just that, right? Again, let's set up a scenario, right? I'm gonna do 1, and that's going to be a U16, and it's going to have 32768 in it, and I'm going to have a 2, and that's a U8, and he's going to start life as, you know, 76. So far, so good. This is an okay assignment, that's an okay assignment. But then if I say, oh, you know, 2 should be 1, okay, that's going to generate an error. Technically, the error it's going to generate is, you know, it's a type mismatch, really, is ultimately what it comes down to. Same thing so this, what the compiler is going to check is the same here as if I had done that. Oops. Helps if I can type. this is of type U16. So the compiler's going to be like, well, okay, you got to cast that, right? Because that's not, I won't implicitly convert that. So that's what I'm doing. Likewise, if I said, 2 is equal to true. Okay, well, that's a bool. This is a U8. That's not, you can't do that. So that's, each one of these should generate an error for the same reason. They're just not the right type. Ranging is, I probably didn't describe that very well. The range is the same thing that the type inference does, right? So it knows that this is within a U16. So it's bigger than a U8, but it's smaller than a U32. So it's the same logic essentially. It's just now we're going to be doing it at the inference happens for the collection of the initializer, right? When we make the initializer, we ask the type inference system, hey, what's the type on the right-hand side? So I mean, technically, I don't need that, right? The compiler's going to pick the right thing. Well, the same mechanism that allows that to happen is what I'm going to use here. It's just that the difference is here the type is coming from the compiler. And so obviously if I put a huge number, right, that it can't, doesn't fit anywhere. Okay, that's going to be an error. That doesn't fit. I would hope. I'd have to double check the code to see that that's the case. But yeah, this should not resolve to a type because it's outside of range. So let's see, narrow to value, what am I doing? Oh, see, okay, yeah, this is bad. Byte, okay. Because if it's outside of the range, then we're just saying it's U32, that's not good. So let's change this to unknown. And I guess while I'm at it, okay, so our narrows now are going to return unknown if the type, there is no matching type name. Yeah. So here we're going to try to infer the type. So let's do that. This should blow up because there's nothing that fits. Yeah, well, and of course the other thing too is that the compiler is actually translating those numbers. So we're actually not getting a type error. The parser can't convert it into a valid number at all. So we're actually getting stopped at that point. So it's not going to allow you to specify something that's way outside of range. right? It has to be within range. Okay, so then this is going to find a U16. Yeah. So 1 is a 16-bit value, 2 is a byte. All right, so now so what I was thinking is, okay, for in program, we call compile. So this is the top level entry point for compilation. We do our resolve unknown identifiers, resolve unknown types. Then we do the code emit. So I'm thinking here is where we would say, if not, type check. R. Okay, so for type check, we're going to ask the element map, give us all the identifiers, and if the variable has an initializer, then we can skip the type checking, because no, is that true? It should be. Right, we should be doing that at that point. Because we will know everything we need to know in this scenario when that happens. Meaning this. Because the word to do is in modern tools and environments is way overused. Because the IDE has a concept of what to do means, and lots of other third-party libraries use to do. And I don't want to get their to-dos. I want to get mine. So in general, XXX, well, first off, XXX has been used in C and C++ for a long time. And I don't know that it predates to do, but it certainly has been around quite a while. And it's unique, right? It's more unique. So I tend to get far fewer false positives by using XXX than I do to do. If I were to search on to do, I probably will find shit. Yeah, I'll find stuff in other people's code, right? Because that's what everybody else uses. But if I search on XXX, look, it's all, with the exception of, okay, so the UTF-8 guy, he did it too. And some of the regex stuff in Boost. But it's less, right? So, and it's habit. It's like everything. It's just habit. That's what I've been doing for a very long time. And okay, so this isn't really quite what I want. So you know what? Actually, so we need to do okay. So we're actually going to do two things. We are going to check where there's actually an initializer. So if variable, I will do this way, init. So if there is no initializer, we're going to skip that. Otherwise, if variable type is not equal to initializer, infer type, Okay, so then we're going to loop through all the binary operators looking for assignments. And okay, so then we're going to, so this really should never fail. It'll be interesting if it does. These, we're going to look for, now we're looking for these kind of assignments because the variable already exists. This is actually going to generate code that's going to load the value on the right hand side and store it into the memory location on the left, which could be, you know, global, or it could be on the heap if it's, you know, heap allocated, or it could be the stack. It doesn't really matter. And we don't care about other binary operators. We just care about the assignment. We know on the left-hand side, at least for now, of a binary operator, it's always an identifier. Now with destructuring and multiple assignment, that actually might be something else, potentially. So I'll have to revisit that. But we know the identifier has a type because it's already been defined in this scenario. So we're going to compare the identifier's type to whatever the right-hand side type inference is. So here, the compiler is going to tell us this is a U16. And the compiler is going to tell us this is a U16. And the compiler is going to tell us this is a Boolean. On the left-hand side, the type is U8. So these should all fail type check. I say should. Eventually it'll work. I don't know if it'll work the first time. Do you work a full-time job apart from building this programming language, or is this your full-time job? Asking since you stream for 3 to 5 hours every time. I do not. I've been self-employed for a very long time. With the exception of a very short period between 2007 and 2010. Okay, see, that's bad. Lab blade. That should have failed. That should have failed. good. That's not good. Oh, procedures. Yeah. I haven't really done that yet. So it's obviously adding the errors. Yeah. Namespace. Why is why isn't that? Why didn't that? Oh, that would be why. Oops. Okay. Thought I had done that. Evidently not. Yep, that's the plan. Okay, so that should solve part of it. Okay, so we're actually getting a type now. On the right hand side, we're getting a U8. Yep. And the variable has a type of S8. Ooh. S8. Yeah, okay. That's actually, it should be easier. Okay, so now okay. So now the signed versus unsigned. They're all gonna error out. All right, so now we're getting down into the binary operators. So variable here has a type of U8, and okay, in this case, the right hand side, return a type of null. So it's a symbol. Oh yeah, okay. There we go. All right. Hey, Vinal. All right, temporarily. We'll come back to those. thought I had fixed the location on binary operators, but maybe not. There we go. I mean, that's, yeah. Okay, so this is fine, but yes, assigning a uint to an u8 is incorrect. Assigning this would be a u16 to that. So let's make the error message better. Oh, right, the identifier. so for a symbol element, if we infer its type, we try to look up that symbol as an identifier in the program. If we find it, we return its type, otherwise null. Oops. Okay, so we don't get the null pointer exception anymore. Perfect. All right, so it finds the variable 1. It knows it's a U16. It knows 2 is a U8. Can't do that. Okay. It knows that this literal is a U16. Can't assign that. Yeah, and it knows this is a bool, and now you can't assign that. Good. Right, now the rest of these, okay, so then we have a bunch where it's assigned type, and then we have a unsigned representation of that. And this is an interesting one, right? Like, because notice this one didn't error, because that's valid. Technically, this is, yeah, see, this is goofy because there's a couple ways I could do the signed to unsigned thing and vice versa. Although signed types would fit in unsigned. I could say, okay, the target is signed, is, yeah, it's 80 hex. So I mean, these three are the same as this, but they're the 2's complement representation. So I could either do that, right? I could either say, okay, the target is signed. Is the right-hand side a valid 2's complement of that type? And then allow that to happen. Or we could just require a cast here, right? And the cast, instead of the compiler assuming in that scenario, the cast tells it, hey, this is valid. But oh, that's interesting. That should fit. Oh no, yeah, okay. Yeah. Yeah, see, this is in range. So that's when I was talking about the range checking. So part of this with the numerics is, you know, yes, this is a U16, and yes, this translates to a U8, literally, but a U8 fits. So we have to, you know, I want to allow that because otherwise it just gets insane. You'd have to cast constants all the time. So so I have type check returning true, which is probably, I gotta change mine. Not. So I'm pushing the actual type checking into type, dot type hierarchy, because then in numeric type, I have access to all the innards of all the other numeric types. Cannot assign, oh, because bool is different type. So that should fix bool. And bool is easy because there is no implicit conversion. Like 1 does not implicitly become true, 0 does not implicitly become false. You could cast them, but all right, good. Now the reason I succeeded is because I'm returning true for all the numeric types right now. So now this is one of those interesting double check scenarios. Double pivot. If we get nothing in as the other type, they're not a match. If the names match, it's U8 to U8, then we're fine. Okay. Good. All right. So So if the other type that we're checking against is signed, then we want to know if we're in range. That's a good question. I don't know if there's a de facto standard for it. Like, I know most, so Rust is maybe pretty strict, meaning that mixing literal types, like in the example I have here, where I have a bunch of, the literal translates to an unsigned value, but you're trying to assign it to a signed value. Like Rust doesn't let a lot of that stuff pass. You have to actually cast it. I mean, I guess if you want the most type-safe language, you would force the developer to cast all this stuff. However, the problem is that's going to get really verbose. And while I want to limit the amount of implicit translation that takes place, like I think in cases like this, I don't know. But yeah, to answer your question, I'm not really sure. Yeah, C and C++ are not really good examples, in my opinion, of C and C++ are just full of weird implicit type conversions that, like stuff like that, to me are just, that's just confusing. Well, what they're saying is that int is larger than char. So because signedness is coming from the sign bit, okay, so you take a 16-bit value, right? We'll take the simple case. You have an 8-bit value. The sign bit is the uppermost bit, right? And then you take a 16-bit value. Well, now in a 16-bit value, that 8th bit, that's not the sign value anymore. That's just some bit that's part of whatever that 16-bit value is, right? So now if you take that and you stuff it on top of a byte, well, what was your signedness, right? Because the sign bit is always the most significant bit. That's how 2's complement works. But the most significant bit, obviously, right, is shifting to the left as you get larger and larger. So yeah, you're hitting this truncation problem, and yes, the compiler's taking that and saying, okay, well, I'll just throw the upper 8 bits away. Or, again, in the case of like a 16-bit to an 8, an int would be 32 bits, so it's going to be throwing away the upper 24 bits. And I don't even want to get into that kind of situation. Like that definitely would require a cast. So, up here in this case, right? So I have a 16-bit value and I have a 8-bit value. Here, there's no implicit here at all. This will always fail. You would need to cast this to a U8 for that to work. Because then as the developer, you're explicitly saying, I understand that I'm going to throw away the top 8 bits, and that's okay. Same thing here and here, right? If you cast this to a U8, you're saying, I know it's going to become an integer value, right? But the gray case, the gray area is stuff like this, right? Where this has the same bit mask, right? These all have the same bit mask. So it's not a truncation, it's not out of range. So then, but with that said, it is, I could see that being confusing. Like if I have a signed byte and then there's some code somewhere where you're assigning you're assigning a positive value, you're assigning the two's complement, essentially, directly. So there's two ways I could interpret this, right? I could interpret this as, yeah, this actually is in range of this type, or no, you have to cast that. Yeah, and see, that's the other thing too. Like auto promotion is super confusing. So I don't want to do anything like that. And then, you know, as far as like warnings go, when we could do that, the worry that I would have there is I don't want to go down the Rust path of having, you know, the compiler spew out 5,000 warnings, you know, that are all like some trivial, you didn't use this, you know, you should cast that. I mean, I guess I understand the school of thought there, but and actually, I think what we want to ask here is, are we signed? Oops. Yeah, my only concern with that, again, is I worry that we'd end up doing lots and lots of cast potentially. But I don't know, maybe, I mean, I'm inclined to agree. I don't want much implicitness. But then at the same time, like, I watch videos of like John Blow working with Jay, and he has, I think, fairly strict casting rules. But then he ended up adding that XX operator, right, where you can just auto cast, right, just do the right thing, and he uses that a lot. So I don't want to end up in a similar situation where I have to have like a, oh fuck it, I don't want to deal with casting, just cast. You know, just go, right? Well, yeah. That's why I think what I was going to do is sort of compromise, right? Like, I'm going to do kind of a cross between the only exception I was going to make was, okay, if you have a signed type and then you have an unsigned value over here, but it's an unsigned value of the same size, right? Then it'll just implicitly accept it. It's like to Mr. Anderson's point, right? Because this, a U16 and S16 are the same number of bytes, they're the same size. So as long as the two types are the same, but the only difference is their signedness, then I'm thinking I'll just let it pass. Now, if it's a different size, then yeah, you're SOL, you need to cast. But because then to me that logically makes sense. Yeah, the autocast thing scares me. Like I don't. To me, I watch like John and write code, and then it's like XX 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 XX, and then people are always like, "What's XX?" And then they're the little bots like, "Oh, XX is the autocast operator," and it's it's like, okay, well if you've made your language so strict that you're constantly just autocasting everything, then what's the point, right? And I don't know. We're only dealing with numeric types here. It might be that even just allowing unsigned and signed variants of the same type to pass through is still too strict. So what we need on numeric type is we need a helper that will give us, given the type name, it'll give us the opposite, right? So if it's unsigned, it'll give us the signed version. Sure. Okay. I mean, again, I've only seen a couple videos where I've seen him use it. It just seemed like he was using it a lot. But yeah, I don't know. Like at that point, then why not just use a cast, right? And I don't even know what casts look like in J. So I think they look like C-style cast, but hey, Soding. Yeah. Yeah, okay. So his is very similar to mine then, because I was doing this. So are both types signed? Is other numeric type smaller, or is it smaller? Yeah, that's why, yeah. To me, this, now look, this is like the C++ style cast. This is kind of like a function type version of it. I personally like that syntax. I find it easier to read, but right, but they are long to type, yes. So that's the downside, right? Is, again, I'm okay with Basecode having more cast than like a C or other languages, but at the same time, I don't want to force developers to like have to be cast happy everywhere. That gets kind of ridiculous really fast. Okay, so here's what I'm thinking happens. Okay, if both types are floats, right, they weren't, we've already covered the case where they're identical. So if they're not identical, but they're both floats, and the right-hand side, which is other, is smaller than this, meaning the right would have to be an F32, then they're equal. Which, so that's an implicit for assignment purposes. But again, I think that's okay. I'm okay with that, because you can assign a 32-bit float to a 64-bit float. If it's not floats, then are both types signed? If they're both signed, then both types same signedness. If they're the same signedness, then is the right-hand side smaller than the left? If it is, then they're equal. If they're different sidedness, then is the right-hand side the same size as the left? And then if they are, so in other words, if you have a U8 and an S8, if you have an S8 and a U8, if you have so on and so forth, then in that case, that's okay. But if they're different signs, then the only case that's valid is if what you're assigning to the left is smaller or equal. If it were equal, though, then we would have caught this. Well, but see, that's the problem, right? Is then we get this, that's like autocast, right? What Kubicus is suggesting, and I don't know. There's just something about the autocast thing that feels off to me. I mean, in general, I'm all for taking the attitude of, look, the programmer knows best, let them blow their foot off if they want. But at the same time, I think, yeah, that just feels like a MacGuffin or a Deus Ex Machina type solution to the problem. Like, oh, yeah, I really don't want to think about how these types work. Just go, just make them work. Okay, there's floats. So if they're both float and the right-hand side is smaller than the left-hand side, then it's okay. So that should solve the float assignment case. Yeah, I guess it depends, right? Again, that's like I fully understand the perspective of, hey, don't treat me like a child, you know, if ooh, hey, oh yeah, do. Because I guess you could pass. Duh. Yeah, don't treat me like a child. I know what I'm doing. You know, in this case, I'm going to do adult stuff. Close your eyes. But then, you know, I understand, like, the desire to want to try to prevent people from writing code that's bad for them. Okay, so the float scenario is fixed. So it allows the float assignment now. So now if we say is signed and other numeric type is signed, then return other numeric type size in bytes is equal to, right? So here, if we're the same No, sorry. This other is less than this. And then this one is return other numeric type, size in bytes is equal to size in bytes. So, okay, we try to cast the incoming value, the incoming type to numeric type. If it isn't, we're done. If the type names match, then we're done. They're identical. If they're both floating point and the right-hand side is smaller than the left, that's okay. If they're both signed and the right-hand size is less than, because obviously if they were the same, they would have matched. So if they're both signed and the right is less in size than the right, then that's okay. Otherwise, we have a signed and an unsigned type. The sizes have to be the same. Okay, well that's a legitimate error. That's legitimate. That's legitimate. Because those would require casts. This, though, why is that not working? Oh, wait, it would be, duh. It'd be less than or equal, right? Yeah, I mean, that's an interesting idea. Cache override says have a bunch of explicit translations, right? Promote, truncate, signed. I mean, okay, so this is interesting. Can it assign S64 to S32? How's it figuring that as a S64? Yeah, again, that's the only, thing that concerns me. Okay, so these are all perfect. This is exactly what it should be. Yeah, but this one, oh, has it? Oh yeah, that's because the app died. I think the camera died. Hold on a sec. I'll be right back. Oops. And my microphone came off. Truncate camera. Yeah. Yeah, I ordered a continuous power supply for it, and I ordered the HDMI cable, and the batteries just really don't last very long. Yeah, the low frame rate from the camera will be fixed when I get the HDMI wired up. That'd be awesome. No. Here's what we need. We need a fuck off attribute. You can just tell the compiler, fuck off. Don't type check. I know what I'm doing. Yeah. Well, they would tell you they have it. It's called unsafe. Except, yeah. No dynamic typing. No. Okay, so we have one case where, no, I'm not writing JavaScript, damn it. Everything's afloat. Yeah, we all float down here. Which one is it? S32 menu. This one. I'm one off. Okay, so the only errors that should be left are the ones I did at the top where the types absolutely don't match and would require a cast. Yes. You can't assign a bool to a byte. You can't assign a 16-bit value to an 8-bit value. You can't, 16 to 8. Can't do that. Okay. So now, let's put our initializer errors back in. Most of these should be, well, with the exception of the procedures. Okay, so this is where procedure type. Hey, Raul Rita. Going pretty good. Getting some very basic type checking in here. False. That's a good question. Who checks the type checkers? Mr. Anderson. Okay, I think that's gonna allow everything to pass here, maybe. Okay, where are we left? What are we left with here? Ah, see, that's a typo. Interesting, cool. Thank you. Perfect. All right. So the only errors we're getting now are these right here. Everything else is fine. So if I comment that out. There we go. No errors. Everything's resolved. Very good. Super awesome. Okay. So what I would probably do, I'm going to create some issues around this. Like type, I would like to add a equals method, or maybe I'll override the equals operator. But instead of comparing, names and symbol names and stuff, I'd like to have a method that actually does the real comparison on their covers, especially like for procedures and structs and stuff. Equality is going to get a bit more complex. So right now, I mean, what I just did, it works. It's basic. But I need to go through and add an actual custom comparison to type so that we can do unique comparisons for the more complex stuff. But it's good. So now, like, I can't come in here and say, you know, Bing is a string, and then say bong is a U32, and then try to assign Bing to it. Although, actually, that's going to fail twice, I think, because I didn't add, well, yeah, I don't know, we'll see. I think string is a composite type, so it probably is okay. Yeah. So you can't assign a string to a number. Woohoo! It works. So awesome. All right. I feel like I'm actually making some progress. Cool. All right, let's review that. So short, I can probably just revert this because I just used this as a test. In our simple file, I fixed one typo. So the type checker now actually, this is larger. It doesn't fit, right? So it caught that. And this actually should have been an octal number, not a hex. It caught the fact that this was was out of range. Now the error message here is a little bit confusing. And so I definitely need to probably add some better code around, like if they thought it was assigned type, or they tried to make it assigned type, here I might want to show like, okay, hey, you were out of range. So I fixed those. Yeah. So that's great. And type, I added type check, and you pass in another type. And I just follow the same pattern I'm doing everything else. I have a protected virtual method that can be overridden in subclasses so they can customize what that means. Symbol element, we implement onInfer type, which what this does is this goes to the program, says, hey, given myself, can you find this identifier? If we find it, we return the type for it. Otherwise, we return null. Program, added a friend class for symbol element, added type check, and then the implementation in compile, we call type check before we start doing code emit. And then type check is 2 loops. One, we loop over all the identifiers. And if there's an initializer, we assert that the initializer the type of the initializer matches the type of the identifier. And then we loop through all the binary operators, and we filter everything out but assignments. And for assignments, we know on the left-hand side we have an identifier. And then we infer the type on the right-hand side. And then we compare the type of the identifier to that right-hand side type. And if they don't match, you get an error. Pretty simple. Procedure type, we override on type check, and we compare names for now. Numeric type, this one has a bit more complexity in it. Don't need that one anymore. So first, I fixed the narrow to value for floating point numbers. I wasn't explicitly checking both ranges. Now I am, and if neither range is valid, we get an unknown. For integers, same thing. If nothing ever matches, we get unknown. On type check, for numeric types, so we try to cast the other to a numeric type. If it's not, then they're not equal. If the names match, then they're the same type. If they're both float, then the right-hand side has to be smaller than the left-hand side. So you can assign an F32 to an F64, but you can't assign an F64 to an F32. If they're both signed, then the right-hand side has to be less than the left-hand side. If otherwise, if they're of different types, or different signedness, sorry, then as long as the size of the right-hand side is less than or equal to the size of the left, then it's okay, it's permissible. Namespace, override on type check, and we just compare names here. Module type, same thing, we're just comparing names for now. Initializer, I overrode on infer type, and I passed that through. Composite type, on type check. For now, we're just comparing names, but that's going to be more complex down the road. Boolean type, override type check, and we just compare name. Actually, here I'm comparing the element type. So I suppose that works too. Either approach works. So that's, and then we also did the no color command line option. We got those three sort of addressed. All right. So I think probably the next thing would be to try to get the cast operator behaving a bit more, doing a bit more than it does now. And then figuring out like what the code generation for that looks like. Because we could put those test cases back in where I'm trying to assign the wrong types. We could then use the cast and make sure at least the basics there are functioning properly. Okay. So that's 3 of those. Oh, because I used added. Yeah, all right. Okay. Cool. So, got a lot done with only 2.5 hours. So I'm pretty happy with that. All right. I'm gonna push, or actually I already did push them out. All done. Yes. Okay. I have to run. So let's try to find somebody here real quick. Anybody from DevSauce besides me? dev W. Right? Yeah. Let's rate him. Oh. Okay. Oh, it's dev VVV. There we go. All right. Say hi to this guy. I'll be back online tomorrow, 5 a.m., and we'll work on more stuff. Making pretty good progress, so I'm happy. Thanks everybody for dropping by, and I will see you tomorrow morning. Have a good one. Here we go. The raid commences.